All right, in this video, we are going to talk about exceptions in Java. So, an exception is an event that occurs uh, in a program or when you're executing the program, where the normal flow of instructions has been disrupted. So, basically, something went wrong in your program. And you've seen this before, probably when you are writing your program and it runs, it compiles, and then you run it, but then midway through the execution of your program, it crashes. And in JGrasp, you'll get a bunch of green writing, or in whatever IDE you're using. So an exception is also known as a runtime error. So something, issue or problem that happens when you're running the program. All right, so in Java, when this type of error occurs, the method that you're in will generate an exception object. Okay, so and that exception object has information about the error, where it occurred, and various other things. Okay, so when a method generates this exception object, that is called throwing an exception. You'll read and hear people say, "Hey, that threw an exception when I did that." Okay, so that's kind of the terminology involved. All right, there are a bunch of different types of exceptions. All of the exceptions are child classes of the exception class. So if you go to the Java documentation, and then you can look for these various classes, right? There's throwable. That didn't quite come up how I wanted it to. Here it is. There's throwable. And then throwable has child classes exception and error. All right, so you can see here it lists the child classes, and we're interested in exception mostly. Okay, so here's exception, the exception class. You can see all of its child classes here, right? Direct child classes. So there are a bunch of child classes of exception. It implements this serializable interface, which we'll talk about in the next chapter. All right, so here are just some child classes of the exception class. The error class, we won't talk too much about that at all, because normally the error class, that has to do with like things that go wrong that are sort of beyond the scope of your control as a programmer. So there's really not a huge amount that you can do about it. So we won't spend a lot of time here. We will spend all of our time talking about exceptions. Okay, so exception has some child classes, and you saw those listed in the API in the document here, in the Java doc about exception. One particular class, subclass or child class of exception that we'll talk about it's called runtime exception. And so that should be in here somewhere. There it is, runtime exception. And it has a bunch of child classes, and you can see all of those as well inside there. So there's a whole host of those for all of the various situations that can go wrong inside of your program. And so you can see there's a lot of them. All right. Okay, so let's jump right into using these exceptions. We'll take a look at this enterDigit.java program first. It's very simple. All we do is ask the user to enter a single digit, 0 through 9. Okay, and so then we get the digit from the user, and then we display the digit that they entered. All right, so this pops up this dialog box, and I enter a digit. The issue, right, comes in when the user enters a letter or something like that that's not a digit, it's going to cause this line 9 to crash. So if I do that, you can see that I get this message. And I'm sure you've seen this message before, right? And here it will tell us, so this is an exception or runtime error that happened. And you can see the name of the exception, right, that was generated. It is a number format exception, okay, for input string G. All right, and then you have what's called the stack trace right here. And this error, you can just kind of see how this error propagated through the method calls. All right, so that's what this is called, the stack trace. And then it traces it all the way back to the source, right, of the error. And that is line 9 right here in the enter digit program. So it was right here. And it was caused by the user, right? The user typed in a letter, and then Java tried to change that letter into an int, but it gave up because it has no rule for how the letter that I typed in is supposed to be interpreted as an integer. All right, and so it just crashed right then and there. All right, so in this case, that bad input generated a number format exception. Up until now, if you've had me as a teacher, you know, I've said, yeah, just pretend that the user is perfect, right? Even though I told you that's always, you know, far from the case. And so I've kind of put off a lot of the error handling until now, and that's because we have now a decent way of handling that situation. Okay. So, and that's through the use of exceptions. All right. So an alternative to just letting your program crash, right, when the exception is thrown, is that you can add a block of code that tries to recover when that exception is generated. Okay, so that block of code that you add in there to try to recover is called an exception handler. And that process of recovering from the error, from a thrown exception, is called exception handling. Okay, and so the terminology, just like we say that the exception is thrown by the method or program or whatever, then that process of handling the error, trying to recover from that, is called catching the exception. All right, so the method throws an exception, and then you as the programmer add that block of code, the exception handler, to try to catch the exception. So that's the usual terminology involved with that. Okay, and so now the specifics of how you would do that in Java is through what's called a try and catch statement. Okay, so the basic try and catch statement looks like this, and I say basic because there's another version of it, try with resources, that we will use, but we're not going to talk about that until the next chapter on file input and output. All right, so the basic try catch statement looks like this. First off, you would have the keyword try and then a block of code after that. And so what goes in this block, the try block, is the code that might cause a problem, right? So in that case of the enter digit program, it was this line number 9 that was causing the issue. That would be what we would put into the try block. All right, so we would put that in there. Then after the try block, you have to have a catch block. Inside the catch block, you will have an exception type in here. So, and that would depend on what type of exception that you think this code might generate. In our case, right, it would be this number format exception when a user types in a letter. Okay. You should be as specific as possible about the exception type. Okay, it's lazy to not be to not be specific about it. So again, be specific about this exception type. You'll have to have some name for that exception. A lot of times I just use E right here, E for exception, but you can use any other variable name that you like here. And so what goes inside this catch block is the plan to recover from that exception. All right, so here try is you're telling Java, hey, be careful, right here something bad might happen. And then this part is, okay, if something bad happens, here's the plan for how we're going to handle that. All right. You can have many catch blocks. So your code in here, it might cause a couple of different exceptions. If that's the case, then you can have many catch blocks after the try block. You have to have at least one, right? But you can have many for the different types of exceptions. So you can have more than one plan. Basically, it's kind of like saying, hey, if this type of exception happens, then here's the plan for that. If this second type of exception happens, here's the plan for that, and so on and so forth. Okay? All right, so then after the catch block comes the finally block. And the finally block is optional. Okay? The optional block, right, or the optional finally block, what it does is it's going to execute regardless of what path that the execution takes through here. So, and we'll talk about how that flow goes through the try and the catch block. Regardless if it goes through the try block or the catch block or some combination of that, it's going to execute this code in the finally block. So the finally block is basically like the cleanup code. Okay, so maybe something went wrong, maybe something different went wrong, right? Didn't go wrong, right? And so, but regardless, right, of whether something went wrong or not, this code is going to get executed. So a primary example of that would be, say, if you are reading file input and output, and again, that's what the next big topic that we're going to discuss after exceptions. And in file input and output, what you have is you open up a file, and then you read from the file, and then you close the file, let's say. That's file input, okay? And so regardless, right, there's a whole host of issues that might happen, right, in file input. Maybe you can't find the file, right, to open. And so maybe it never gets opened. Or maybe, something goes wrong in the process of reading from the file, and it throws an exception. So there's a bunch of things that can go wrong. But no matter what, right, if everything went perfectly or if everything didn't go perfectly, at the end of that, you would want to close that file, right? Because leaving it open can corrupt the data that's in the file. So that's typically kind of a typical situation where you might use this finally block is to close the file. Now, in practice, I already mentioned to you about the try with resources statement. That's way better than using the finally block, especially for that situation I talked about. So we'll end up not using the finally so much. The typical use case for that in our class will be using the try with resources. Right? But there's still other situations where this finally block comes into play. Okay. Okay, so that is the try and catch statement. All right, so try tells Java, hey, watch this code for something that might goes wrong. Catch, right, is the block that tells Java what to do if something does go wrong. And then the finally is basically the cleanup block after all of that situation is over. All right, so now what we need to know is how does execution go through the try and catch block, all right? So we're just going to basically break this down into two different cases. Case number one is that there's no exception. Everything goes as planned. There's no problems whatsoever. All right, so what's going to happen is if no exception is generated in the try block, the flow is going to go like this. All of the statements in the try block are going to be executed in order, and if there's no problems, then all of the catch blocks will be skipped. All of the code in the finally block will get executed if there is one, and the statement following the try and catch block is going to get executed. All right, so if everything goes smoothly, all of the statements in your try block get done. It's going to skip all of these. Every piece of code in the catch block is going to get skipped. In the finally block, it will execute any of that code if it's there, and then move on its way to the next line after the try catch block. Okay? So that's if there's no problems. Next up, if the case is, let's say something goes wrong in the try block, what happens? Okay? So if something goes wrong in the try block, execution goes like this, right? If something goes wrong in the try block, then that is going to be the last statement. None of the statements after that point where it goes wrong will get executed in the try block. It will immediately jump to one of the catch blocks. It will search all of the catch blocks for an exception type that matches. Okay? And so execution will jump to that first matching catch block. Okay? If there's no matching catch blocks, the program's going to crash. It means you didn't have a plan in place for the exception that got generated. All right? So if then after that, the statements in the finally block will get executed if there is a finally block. And then the statement following the try and catch block will get executed. All right. So going back here, just summarizing that, right? So execution would kind of go like this. We'd have come into this try block. Any code that's in there will start trying to get executed line by line, right? If it's, say, like you had 10 lines and it's the first line that throws an exception, right? That means it will immediately jump. None of the subsequent lines in the try block will get executed. It will immediately start searching these catches here. So basically it's, hey, something went wrong. I'm going to look for the plan that I'm supposed to execute. And it will try to match the exception type. So if it finds one that matches, it will start executing that code that's in the catch block. It will start executing the plan, right, for what went wrong. After that, it will jump to the finally block and execute all of the code there, if there is one, and then it will continue on its way, right, to the next statement that's after the finally block. All right? So that is the flow of execution with the try and catch statement. All right, so I think we're kind of to the point where we can start actually working through an example of this. Okay, so we're going to go into this enter digit problem that has the issue with when the user types a letter, then the program crashes, and we're going to try and fix that with a catch block. Okay, so here we go. All right, so here the issue is line number 9 right here, right? That is causing the problem when the user types in anything other than an int. All right, so that's what we were going to do. We are going to add it into a try block. Okay. So that is telling Java, hey, this code right here, this line, or these statements in the try block are known, right, to cause issues with right? And so watch out for it. All right, adding it in the try block though is not enough. You're going to see that there's going to be a couple things, right, that happen here. So I'm going to compile it. It's not going to compile, right? If you try to add a try block without a catch block, finally our resource declarations, it's going to give you this error. All right, so like I said, a try block has to have this catch in here. So we need to put in the catch. All right. So I put a catch block on there. Going back up, it was number format exception, right? That was the type. And I'm going to give it a name, right? Which is E, okay? And then, let's see, it might work. It might not complain about not having the catch. But there's something else that goes in here. So actually, before we go on to the next error that's going to come up, let's just go ahead and put some plan in place, all right? So what plan should you go with? That really depends, and that on the situation itself. There's lots of different things you could try to do. So the easiest way out, right, of any situation like this is just to quit the program, okay? So that's not always feasible, but I'm just going to add something in here. So I'm just going to say invalid input, and then I'm going to quit. So that's system.exit 0 to quit, or you could just put, since this is in the main method, you could just put return out of here as well, and that would work. All right, so that's my plan. I'm not saying that's a good plan, right? If you're writing software for commercial purposes, right, your users are, and your program just quits out of the blue, right? People who are using your program are going to say, hey, well, this program's no good. Why am I using it? So that's not the best plan. So we'll modify this as we move forward. Okay, so I've got a plan in place, and now when I'm going to compile this, I'm still going to get another error, and this error is typical, right, of what happens in here, okay, when you're doing this. All right, so when I compile, right, it says error cannot find symbol. And again, this is very, very typical of something that you have to do when you're implementing these try and catch blocks, okay? So you can see now the error is down in line 19, and it says, hey, I've never seen this digit before, this variable. You're trying to use some variable, and you never declared it. So Java's saying, I don't know what to do, okay? And you say, well, look, the declaration's right here on line 11. What do you mean, right? It's right there. How can you not see that? All right, and so the thing is because you put this variable declaration in this block, remember how Java deals with the scope of variables, right? The scope of a variable is the block in which it's declared, right? So by adding these parentheses, I've made it so that I can only use this variable digit in this block from 10 through 12. And so that's why Java now is all of a sudden complaining. All right, it's an easy fix, right? But you have to have encountered that before, usually, to know what to do. The fix is to declare that variable up here. And then that's still not going to fix everything, because Java's going to complain that you already declared digit up here in line 9. So you would get rid of the int, right? So now it's just an assignment statement and not a variable declaration up here. All right, again, so that is very, very typical of something that you would have to do when you're adding this try and catch block in there. You might have to move the variable declarations before the try block if you want to use those variables later on in the program, okay, later on in the method. All right, so that compiles. Let's run it, and we will see that when we type a letter now, we get invalid input, right? And this pops up. Actually, I don't like that because we're using JOption pane, so let's use JOption pane dot show message dialog null invalid input. All right, so if I type a bunch of letters, right, it says invalid input. And since we're quitting the program, let's warn the user as well. Terminating program. All right, so that's better that the user at least knows what's going on right here, even if it's not good. All right, so you can see we fixed that situation where it was crashing the program, and that's a much better situation, right? The program does not crash anymore. All right. The user enters non-numeric input, display a message to the user, and terminate the program. All right, so far so good. One thing is a lot of times, just showing you something that happens to me sometimes, is I forget to return out of the hit return or put a return statement or system.exit 0 to terminate out of this catch block. So if you do that, if you forget that, it'll compile and run. But then the situation is if the user types some letters, right, we're going to see this message about the invalid input terminating program. So we'll get that message, but then we'll also get this message because it will just continue to run after the catch block. So here you can see I get this just like you would expect on line 16. And then if you forget to put the system.exit 0 or return, then you'll get the message in line 20 as well. So you can see that this popped up and it says you entered the digit 0. Okay. Sometimes a lot of times you do want it to run right past and keep going, so you wouldn't put the system.exit 0, but sometimes you don't, right? And if you forget that, the main thing to know is that the lines, the statements after the catch block will get executed if you don't specifically tell it not to. Later on in this example, that's what we're going to want. Okay. Okay. Next up, we're going to talk about the throw statement. And the throw statement is used to cause exceptions in your program. So a lot of times you might say, well, why should I do that? Why should I cause a problem in my program and crash it on purpose, right? The thing is that just like exceptions, right? They signal to the program that, hey, something went wrong. You can use that to your advantage as well. So you can make your own custom exception objects and throw them to indicate some unusual problem or something that's in your program. Okay. And you, like I said, do that with the throw statement. So throw and then new, and then whatever type of exception that you're trying to generate here. So you can use that to your advantage in the problem, right? So let's see. Let's go through here. All right. So it says add code to the enter digit.java program example to check to see if the number entered by the user is in the correct range, 0 to 9. If not, throw an illegal argument exception. If the user enters a number not in the correct range, display a message to the user and then terminate the program. Okay. So that's what we're going to do. So inside the catch block, right, what we're going to do is check the digit. If digit is, let's see, it's 0 through 9. So greater than -1 or less than 0, let's say. Or the digit is greater than 9. Throw new, I forget which exception. It's a illegal argument exception. By the way, you can check or search for these different exception types in the documentation, right? So just search illegal argument exception. That's in the java.lang package, and it's one of the built-in ones here. Okay. So we're just using that as an example in this particular one. By the way, I also forgot to show you. We'll get to that. Get to that in a second. Okay. So here I have a thing to check, right? An if statement that will check to see if the digit is in the proper range, and if the digit is not, if it's less than 0 or bigger than 9, right, then it will throw this new illegal argument exception. All right, so this time I'm going to type in a digit, say like 56, right? It's not in the proper range. And you can see that crashed my program, right? The reason why was it got here, right? And that digit 56 was bigger than 9, so it executed this statement that's inside the body of this if statement right here. It threw this illegal argument exception, right? And then immediately what Java tried to do is to, it tried to look to see if, that number, if it had a plan, a catch block for the illegal argument exception. Since we only have one catch block, it did not, and so it crashed. So you might say again, why are you doing that? Well, what you can do is add your own catch block down here. Legal argument exception E. And I'm just going to copy this. And I'll just put a different message, invalid range, and then terminate here. Okay. So now when I enter a number that's not in the correct range, like 54, right, you're going to see we get this invalid range terminating program, and the program's over. All right, so that's something you can use this throw to your advantage, right? And then that signals, hey, something's not right. And then down here in the catch block, you can add your custom checker here. By the way, I sometimes when you put this, when these catch blocks in here, there's sometimes you still want to see like the stack trace, the error messages that Java normally throws. And so what you would do is do e.print stack trace right here. And that will show you the messages. Sometimes that's just helpful for you when you're trying to debug a program. Oops, I messed it up. Maybe it's just stack trace. I can't remember what it is. So let me look here. So if I go to overview, actually go here to exception, and the method, it's one of the methods in here. So yeah, oh, that should have worked. Let me see, where did I mess up here? Oh, I got an extra R in there, that's right. All right. So if you put print stack trace in there, then it will, so if I type in some letters, because that's in the number format exception, click OK, then you can see that those messages, right, that are in there. It may look like it crashed because that's exactly the same method, the same output that you see when it crashes, but it actually didn't crash here. We actually exited here. So sometimes it's you want to see those messages to kind of figure out what went wrong, and so you can force it to do that without actually crashing your 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 program. Okay, so I'm just going to take that back out. So that's useful sometimes. I've had, just some big, long, complicated programs where where I had a bunch of error handling in there, and then I had to go back and modify it, and something went wrong, and then you can't, because you have all that error handling code in there. It's really hard to sometimes get to the to what caused the errors. So what you'll need to, when you put that stack trace back in there and see it, then it's a lot easier to figure out what the error is, and then just take it back out. So and there's lots of methods. Those exception objects, they contain other information about what happened, and so you can look through those as well. You can also put your own messages into those by putting them in the constructor as well as a string. And we'll talk about that more next time. Okay, so it looks like we're good on this one. All right, so now we have done a pretty good job of error handling in our program. The one thing though that it's not so great is that our program quits, right? We just do the simplest thing possible when an error happens, and that is quit, right? I quit here and I quit here. All right, and so really don't want that. What I really want is for the user to keep entering that information, okay, until they enter something that's in the proper range. So that's really what we want to do, okay? And so that's what the next in-class example talks about. It says that alter the enter digit .java program so that if the user enters invalid input, a message is displayed to the user, and the program reprompts the user until the correct input is entered. Okay, so there's several different ways you can do that. Okay, one is to repeatedly do this part right here. Okay, so I'll have a while loop that will go through, right, and repeatedly run this part right here. So what I'm going to do is, actually the while loop, right, needs to be here, because that's where we start, up here, and that's where the action starts. We pop up this dialog box. All right, so there's a number of different ways you can do that. So I'm just going to go with true here. So when this main method is starting, this condition obviously is always true because it's just the Boolean value true, right? And then I am going to put all this inside the block, the while, the body of the loop. Because this is what I want to repeat over and over again. Until the user enters valid input, okay? I guess you could repeat all of it, but I just want to keep asking. Instead of quitting, right, on the entire program when the user enters something bad, I want to keep asking them, right? Hey, you entered something bad, try again, okay? All right, so I have this in the while loop right here, and then what I'm going to do, first off, we're going to see that is not going to compile. There's an issue, right? And let's go ahead and compile it. so I can show you. Hopefully it's the one I'm thinking of that pops up. Yeah. This is exactly the issue, right, that I was thinking of. And so, again, you can see we get this cannot find symbol, right? So, and it's pointing at digit again, right? And the thing is that digit, this print statement is outside of the while block, right? And I declare digit on line 11, so the scope of digit is in the block of the while loop, right, which is from line 8 to line 32. And you can see that this line down here where I need digit is on line 34, so it's out of the scope of the program or of this variable right here. So again, you're going to have to deal with that issue right here, so I'm just going to move the declaration up here and take this out. Okay. All right, so next up I get this unreachable statement because this is an infinite loop right here, right? Because I have while true. I never make any effort to get out of this loop. All right, so what I'm going to do, since I used while true, right, I'm going to use a break statement at the appropriate place to end this loop where it should be appropriate. And the appropriate place for the break statement is down here in the last line of the try block. Okay. The things that are going to cause these exceptions are this line right here, right, which is now line 14, and this line right here, which is now line 18. Okay. So if no exception is triggered, it's going to go straight through this try block, right, all the way through with no problems. It's going to hit this break statement. That means that the user gave valid input. It's going to break and it's going to quit this while loop, and it will jump down here to line 35. Okay. If something goes wrong, right, what's going to happen? Say the user types in some letters, right, or something that's not an int. This line 14, is going to generate an exception. It's going to jump down here, right, to this catch block. It's going to print this message. And I need to take this terminating program out and this line right here, so the program doesn't end right there. And I need to do the same thing down here. So if the user enters letters, right, it's going to the user enters letters right here. It's going to jump down to line from line 14. Remember, that will generate an exception. It will immediately jump to this catch block right here and print this message. Then it will continue to the next statement afterwards, but it's inside the while loop, right? So that will be the end of the loop body. It's going to come back up here and repeat the loop again, right, and go through. This time, let's say the user enters an int, okay, but not in the range that we want. It's going to hit this line right here, line 18. That's going to generate an exception, and then it will jump down here, right, to this line right here. And then it will, kind of run through there again. All right. So if everything's fine, it will hit this break statement, jump down to here, and so on and so forth. So let's do all three of those. And let me run it through Canvas, and just so you can kind of watch the flow. So wrong button. Control-Shift-R. We'll run it through Canvas. So enter a digit. Where did that go? Okay, here it is. So here, this time I'm going to enter 5, which is totally correct. All right, so you're going to see that's not, line 14 causes no problems. The digit's in the correct range, right? So it jumps over that, and it hits this break statement. And that drops it out of the loop, and I get this message, you entered 5, okay? And everything works fine. Then the program just kind of continues on its way. All right, next up I am going to enter some letters or other characters that should not be in an int. So there we go. All right, that's going to generate the exception. And we're going to see it's immediately going to jump down here to this block. Right, because that's generated a number format exception. So now we're handling that exception. We get that, invalid input, try again. Then it's down at the bottom of the loop body, right? So then it checks the condition, which is always true, and it repeats, right? Goes back over. This time I am going to enter like 55, right? Which is going to not trigger anything on this line. Line 14 is going to be okay. But 55 is greater than 9, so it's going to trigger this, right? And then it's going to throw this new illegal argument exception. So you can see it will immediately jump down here to the catch block. So it skips that break. It never encounters it, right? And then it hits this message. Invalid range, try again. And by the way, it would be a little bit better if we show the user like what they entered. Because the user never believes, right? That they always think, hey, I did everything perfect. So, all right, and then if we enter 7, right, again, everything's going to be good. It's going to hit that break statement and jump down, and we'll get this message here. Okay. All right, so that's kind of the way it should be. The one thing that we didn't put in there that I think would make it better is, like I said, if we reiterated, told the user what they entered and what triggered this message. Okay. All right, so that looks pretty good. All right, just a couple of more issues that we need to talk about. There are 2 categories of exceptions. The first one is called an unchecked exception. So an unchecked exception is any exception that is a descendant of runtime exception. So any of the child classes of runtime exception or the child classes of a child class of runtime exception, and so on and so forth. If we scroll back up, we can look at some runtime exceptions: arithmetic exception, null pointer exception, index out of bounds exception, illegal argument exception, and a whole bunch of others. Right? So any of those child classes in the documentation, right? You can see all of those by searching for runtime exception, and you can see all of its child classes and so on and so forth. All right. So that's how you would determine if an exception is a unchecked exception. Okay. So the things to know about unchecked exceptions: they are not checked by the compiler. Java's just going to let you blunder into those, and it's not going to worry about it. Okay. And a lot of times, these unchecked exceptions are usually the result of poor programming practices, and it's a lot of times it's better to just fix your program with simpler things than it is to use a try and catch block to handle the exception. So just as an example, let's take a look at this unchecked exception example here. Let's see, go back to browse. Unchecked exception example. And it's here. Oh, that took forever. Okay, so in this example, I've got an array. I ask the user to enter a number, and then I am going to show the array element at the index number that the user types in, right? So that's not safe at all, ignoring a whole other host of problems about how do you know if they type in an int or not, like we just got through. Just another thing right, is that the user, this array has length 4, right? So the user could type in a 7, right, and that's going to crash your program because you're trying to get uh, the element at index 7, right, and it's 0, 1, 2, and 3, right? And so you get this array index out of bounds exception, which is an unchecked exception. So that's what I'm talking about, an unchecked exception. Java's just going to let you stumble into that, and it's going to say, hey, it's your fault. You should have done better, kind of, right? So it doesn't check those. And like I said, this is not really good programming practice here, right? At the very, ignoring the fact that the user could type in an int, right? You should also check to see if the index is valid, right, before you go to access it. So you could just add an if statement here. If the index is greater than or equal to 0 and less than names.length, the length of the array, then do this. Otherwise, give some message like invalid index. All right, so now if the user types in a valid index, that's what they get. If the user types in an invalid index, then they get this message invalid index. So that's an example of an unchecked exception, right? Again, it's really my fault because I didn't have that check in there, right? And I could easily avoid having that exception by doing something like this. I would still have to, to make this complete, I would still have to go back and deal with these other issues related to this. But this example is just to show you an example of an unchecked exception and kind of the preferred way for dealing with those. All right. The other type of exceptions are called checked exceptions. All right, that is an exception that is checked by Java. Okay, so Java is going to look at that and say, hey, you've got to do something about that. And Java, your program will not compile if you haven't handled or put something in there to handle a checked exception. Okay, so all exceptions except runtime exception and its descendants are checked exceptions. So runtime exceptions, all its child classes, all its child's child classes, right? Those are all unchecked. And then every other exception is a checked exception. So again, Java is going to force you to deal with that. So let's take a look at the checked exception example. And this one's a little bit more complicated because of the fact that these are situations where that are just more complicated naturally than the other unchecked exceptions. So here I've got a program that opens up a text file. You can see the text file here. And tries to read some words out of here. And we'll talk about this in particular in the next section. And it's kind of not the immediately next one, but that's after exceptions, the next big topic that we'll do is file input and output. So if I try to compile this, you'll see, right? It says unreported exception, file not found exception, okay? So that means these lines right here, right? This file reader, when I go to create a file reader object, right, then it's going to throw potentially a file not found exception. So if you go to the documentation and look for file reader, right, here's the file reader class, right? And if you look at its constructor, right, we're using this constructor with a string. if you look at that, it will show you it throws a file not found exception. All right, file not found exception is a checked exception, right? And so you have to put some code in there to deal with it. You can't just leave it like it is. Okay. All right, and that makes a lot of sense, right? Java is saying, hey, look, how do you know that even that file exists? It may exist, it may or may not exist. If it doesn't exist, well, what do you want me to do about it? I don't know, right? But that's a very real possibility that we're trying to open a file that's not even on the file system. So there's got to be some. Java says, I'm not having that. There's got to be some plan in place for us to take care of that. All right, and so how you would take care of it, right, is to put it in a try block. And all this code is going to do is to read the first word out of that file, out of that text file, which is just alpha. So that's all this does. But it's a checked exception. Java is going to force us to deal with it. And here I'm just going to take the easy way out to try and keep this as simple as possible. All right, so that should take care of this error here on line 8. All right, so you can see here we get file not found exception. So on some of these exceptions, you'll have to put a special import statement in here. On this one, we could just do java.io.asterisk would be the easiest thing. But when I'm going over these, I just like to show you the bare minimum on the imports that I use. So sometimes you'll have to look up what package this is in, and it's easy. You just go here and try and find it. File not found exception. So you can search for it. You can see that it's in this package, java.io, or this is the package name, java.io.file not found exception. So that's the import statement that you would have to add up here. All right, so that should take care of that error. But I'm still going to get another issue. Oops, that's just system.exit0. I'm still going to get another error right here with this. Unreported exception, IO exception, must be caught or declared, right? So, and that is with this readline method, okay? That's from this object right here, BR, which is a buffered reader. So if I go to the buffered reader, and look for the readline method, you can see, right, it throws IO exception, all right? So you can see that it throws an exception, and that, so you're going to have to deal with it. That is a checked exception, so Java is going to force you to put some code in here, okay? And all we need to do is to add a catch block for that. So we just need a plan in place. And the plan is just to give an error message and terminate the program. Again, just taking the easiest possible way out here. All right, again, I get that issue that it can't find the symbol IO exception, so another import goes up here. Import java.io.io exception. All right, so finally compiles. All right, and it does what we want. It reads the line of the file. So you can see, right, it's kind of long, right, longer than some other programming languages. And that is a knock that some people have on Java, is that it's wordy, and it forces you to do stuff like this, right, with the checked exceptions. But it's also safer that way. So that's kind of, if you look at other programming languages, they might be a little easier to use and more flexible, but it's also easier to make a mistake. Here Java, right, is going to say, hey, no, you've got to have this stuff in place, right, in order to take care of these checked exceptions. So you can see the unchecked, it doesn't even check those, right? With the checked exceptions, you're going to have to add code in there to deal with it.